In section 1 of chapter 5, we're going to be starting our investigation with rational functions. Those are functions that can be represented as fractions. As always, I'm going to start with something that you've learned in the past, some middle school / elementary material, and we're going to expand upon that at the high school level. So first, here's some old school review for you. These should all be problems that you know how to do relatively well. Problem number 1, I have 8 over 14. That's a reducible fraction. It's reducible because the 8 and 14 are both divisible by 2. If you divide the top and bottom by 2, you will get the reduced fraction 4 over 7. You are done. Problem 2, same thing. I have a negative 27 divided by positive 6. The top and bottom are both divisible by 3. 27 divided by 3 is 9, so it's going to be negative 9, over 6 divided by 3 is 2. There's my answer. This is how we reduce fractions. As soon as variables start taking a role, starts to change a little bit, but we're not quite there yet. Problem 13 is when we have a fraction times a fraction. There are 2 ways of doing this. I am okay with either way, but there's one technique that I recommend more than the other because it's something you can do easier without a calculator. The first technique is the way I do not recommend. Multiply top times top. 3 times 2 is 6. Multiply bottom times bottom. 9 times 16 is 144. And now I need to reduce that fraction. So I'm going to divide the top and bottom by 2. That's going to give me 3 over 72, I think. And then, shucks, 3 and 72 are also divisible by 3, so I got to divide this by 3 and divide this by 3. And that's going to give me 1 over 24, I think. And that's my answer. That is correct. Nothing wrong with that. But you might have seen I struggled a little bit because those are some big numbers, and I had to do the reduction of the fraction multiple times. It is correct. If you do it that way, there's nothing wrong with it. I want to show you a faster way. I'm going to copy and paste the problem. Literally copy and paste. Here's the way that I recommend doing it. What I did first is I multiplied and then I simplified. It's easier if you reverse that process. Simplify first, then multiply. I notice I have a 3 on top and a 9 on bottom. You might go, but aren't they in different fractions? As long as we're doing multiplication, it doesn't matter. This could all be written as a single fraction. 3 on top, 9 on the bottom are both divisible by 3. So I am going to divide this 3 by 3. I'm going to divide the 9 by 3. I have a 2 on top and a 16 on bottom. They're both divisible by 2. So I'm going to divide the top and bottom by 2. That'll give me 1 times 1 over 8 times 3, which is 1 over 24. I could do that easier and faster because I simplified. I got smaller numbers before I multiplied, which gives me bigger numbers. Problem number 4. We have a fraction, x squared divided by 8, divided by another fraction. This could have also been written as the following. X squared over 8 over x over 10. I'm going to say something that's fancifully mathematics, but it's relatively simple to understand. Whenever you divide by a fraction, it is the same thing as multiplying by its reciprocal. That's my fancy math way of saying if I have x squared divided by 8, and I'm dividing it by another fraction, it is the same thing as that x squared divided by 8 times that fraction I'm dividing by if I flip it upside down. That's what it means to get the reciprocal. And now I can go through the same process I did on the problem number 3. I have a 10 on top and an 8 on bottom. They're both divisible by 2. I have an x squared on top and an x on bottom. So I have 2 x's on top being multiplied. I have 1 on bottom. This single x on bottom will eliminate with one of the 2 x's, leaving you with 1 left. Therefore, we are going to have a single x and a 5 on top, which gives us a 5x. And we have a 8 divided by 2 is 4 on bottom with no more x's. So our answer is 5x over 4. Here's what's new. Now we're doing the exact same thing, except we're not limiting ourselves to monomials. We're going beyond that. We're dealing with polynomials. That means there are two terms or more. Remember, a term is when you're separating numbers through either addition or subtraction. 5x is a monomial. Negative 3x is a monomial. X divided by 3 is a monomial. X plus 1 is a binomial. There's two terms to that. X plus 17, binomial. X minus 3, binomial. X squared plus 3x minus 6, that's a trinomial. There are three parts to that one. So that's what we're going to venture into now. For the monomial portion, we treat them still the same. Problem number 1, I have an 8 on top and a 12 on bottom. That are monomials. I can reduce each one of those by dividing them both by 4. That doesn't change. But for polynomials, you cannot do reduction like I just got done doing. All you can do is cancel. You can just eliminate. For polynomials, they will only eliminate with their carbon copy twin. X plus 1 will only eliminate with x plus 1. It will not eliminate with x minus 1. X plus 5 will only eliminate with x plus 5. So in this problem I have in red, I have an x plus 1 on top and x plus 1 on bottom. They eliminate because they are the exact same thing. Which leaves me with the answer of 8 divided by 4 is 2, 12 divided by 4 is 3. My answer is 2 over 3. Problem number 2. I have negative 1 over 5x times the quantity of 2 minus x divided by negative 3x divided by the quantity 2 minus x quantity squared. First step, I am dividing. I need to flip and multiply. So I'm going to copy and paste the first part. And I'm going to multiply by the reciprocal, the flip of what I'm dividing by the divisor. All right. I have a 2 minus x on bottom, and I have a 2 minus x quantity squared on top. So there's two of them on top. That means this individual 2 minus x will get rid of one of the two of them that I have on top, leaving you just one left. Other than that, there's nothing more you can do other than you have a negative on top and a negative on bottom. A negative divided by a negative is like saying a negative times a negative. Those would both turn positive. So what we're left with is the answer of 2 minus x, if you want to put in parentheses, it's fine, over 5x times 3x, which is 15x squared. Now the one question I do get asked, and I do want to reference it, even though I technically already said it, you have an x squared here. This will only eliminate with a monomial on top. It will not eliminate with this. So these two are not going to interact with each other because this is a monomial, this is a binomial. Monomials will only interact with other monomials. Binomials will only interact with other binomials. And this would be our answer.
I'm confused.
Problem number 3 I wanted to show because it's something that looks super complicated, but in reality it's not. It is a fraction divided by a fraction. The very, very first step, whenever you have a fraction divided by a fraction, and if some of you might want to skip this step, don't. Don't try and do any math in between. Rewrite it as the numerator times the reciprocal of the denominator. Now that I've done that, now I can start eliminating things that are the exact same on top and bottom. I have an a to the second power on bottom. It will only ever eliminate with other monomials. I have an a to the third on top. So these two a's will get rid of the two of the three a's there. So this a squared eliminates with 2 of the 3, leaving you with 1 left. I have an a plus b on top. In fact, I have 3 of them. I have an a plus b on bottom. I have 2 of them. So these 2 a plus b's will get rid of 2 of the 3, leaving you with just 1 left. And then lastly, I have an a minus b on bottom, and I have 4 of them on top. So this a minus b will get rid of 1 of the 4, leaving you with 3. Therefore, what we have left is a single a times the quantity of a plus b divided by, on the bottom, a plus b cubed. And an a plus b. I forgot about that one. I didn't see that one. Because I have this a plus b, I have an a to the first power, and I have an a minus b to the third power. All I have left on the bottom is this b. That should be a minus b. And it's all over b. And this would be my solution.